Hi, distinguished examining lecturer, I am Marianus Irfan. On this occasion, I will present the result of my research title, Sustainability Strategy for Carbon Sequestration in South Tangerang City using inVEST model and spatio-temporal analysis. This result is a case study in South Tangerang City, focusing on land cover dynamic and carbon sequestration capacity, which can be seen on the map on the right. This research is motivated by global and local urgency. Globally, the data on temperature treat and carbon dioxide concentration indicate an escalation of the climate crisis, specifically large cities like Tangsel, while being emission contributor also have significant potential as a carbon sink to green open space. However, the primary threat of massive urbanization has the potential to degrade this carbon sequestration capacity. In the national context, Indonesia's urbanization will contribute to increase, projected to reach 63.2% by 2035. On the emission side, the land use cover forestry sector play a crucial role, contributing 60% of national emission while simultaneously offering the largest mitigation opportunity through optimal land cover management. This research aims to answer four fundamental questions. 1. How to evaluate the rate of change in carbon sequestration related to green open space dynamic? 2. What factors influence the sustainability of green open space? 3. What is the current status of carbon sequestration sustainability? And 4. How to formulate strategy for enhancing sustainability? Our methodology integrates spatial and ecosystem modeling approach. We utilize Sentinel-2 data for land cover classification, which was then processed using the random forest algorithm and Cellular-Markov model for land use land cover. 2030 prediction. Carbon stock estimation was performed using inVEST model considering four main carbon pools. The rate of change evaluation indicates a carbon stock deficit of 9.6% or 90,028 tons carbon during the 2016-2025. This decline is also reflected in the average carbon density. The long-term trend indicates the necessity of structural management intervention. The forest area trend analysis saw a consistent decline indicating accelerate deforestation driven by urbanization pressure. The land use land cover map illustrates the fragmentation and conversion of vegetated land cover into built-up area. The main driving factor is the land cover change dynamic. Although the increase in built-up only 1.6%, this represents the conversion of vegetated land with high ecological value. The increase in scrubland to 104.9% can be interpreted as ecological succession state or the result of immature restoration program. The 2030 projections show that forests remain the primary carbon reservoir. However, the contribution of built-up land, reaching 66.2% of total stock, indicates the spatial dominance of built-up area, indirectly reflecting the loss of sequestration potential. The land use land cover projection map and the carbon change map for 2025-2030 confirm that degradation will continue in area adjacent to growth center. This spatial analysis is crucial for identifying ecological vulnerability hotspots. The spatial analysis of carbon reserve per sub-district show significant variability. No green open space, Serpong and Pondok Aren have the highest reserve, necessitating different conservation and management priority compared to areas with low reserve. We propose a strategy based on carbon efficiency, ton carbon per hectare, and sequestration target ton carbon. Programs such as the cold zone conversation, moratorium, and river corridor restoration show the highest carbon efficiency, around 209 ton carbon per hectare, indicate that protection and restoration of natural ecosystems are the most effective approach. The carbon target contribution analysis clarified that the cold zone compensation moratorium must be the priority policy, contributing 58.7% of the total sequestration target. This emphasized that avoid compensation is the most pressing mitigation strategy. The strategy also include microgreen infrastructure programs such as urban park development and urban agroforestry, show significant carbon sequestration potential, complementing large-scale conservation efforts. In conclusion, the study confirmed the serious threat to carbon sequestration capacity in Tangsel. We have provided comprehensive baseline data and a test methodological framework for sustainable urban planning. We recommended that finding a strategy be integrated, prescribed fairly into the city spatial planning policies. Okay? Thank you for your attention and time examining later.